yeah, this conception of, oh, you're scientist, a super genius.
Exactly. Hi, I'm Jane. I'm an undergrad student, and today I'm going to be interviewing Claudia Gomes da Rocha, an assistant professor at the University of Calgary.
Well, very nice to meet you. My name is Claudia. I'm an assistant professor in the University of Calgary, affiliated with the Department of Physics and Astronomy.
When in your life did you know that you wanted to pursue physics after high school?
At the end of my high school, I realized mostly three things about myself: that I didn't like math, I didn't like computers, and for whatever reason, I was able to solve typical physics textbook problems, putting these factors together. I thought, oh, maybe physics is a good option for me, and it ended up being the career that I decided to follow.
How did you decide where you were going to go after that? Because there's so many universities, so I think to someone having been in one country their whole life, they might be overwhelmed and not know how to choose where to go.
What really determined my very first move from Brazil to Ireland was networking. I did my undergrad in Fluminense Federal University in Brazil, and I did my whole undergrad in physics there. I also did my graduate studies there. It also where I found really a very supportive team of professors and colleagues to do lots of networking and get really passion for research and teaching physics as well. My PhD supervisor had networks in Trinity College Dublin, and there was an opportunity for me to apply there, and which I did. And it was when I started my first postdoctoral after the PhD and in a more international career. And then once you do this big jump, then you start develop more independency to also start picking your own network. And it was when the other opportunities also appeared, when I started also developing my own network of collaborators, scientists, to see which other opportunities would come next.
With all those moves, how are you sure that staying in research was the right place for you?
That is a very good question. I always enjoyed the research aspect. I also enjoy a lot the teaching, and I wanted indeed to do something that I could exercise both aspects of an academic career. I also started enjoying attending networking events, career advising events. It was when it started also broaden my horizons that academia was not the only path. There is more that a scientist can do beyond academic life, and even I considered doing something else. But when the opportunity appeared, I picked it because at the end of the day, it is what I have been doing all these years. But it was good to know that there would be also other options.
As a researcher, kind of what does your day-to-day work look like? Like, are you working alone or with a group?
A very important question. Yes, I do my research mostly, as I said, my laboratory is a computer. And there are obviously the scientists, the collaborations that we establish to kind of join forces. Everybody knows have their specialties, and we combine the forces. And in many aspects, this research in nanoscience, nanotechnology is also very interdisciplinary. It can also come people to participate from other disciplines, from biology, chemistry, engineering. So no, is there is the moment that I'm doing my focus coding alone, but it's a lot of integration and networking with collaborators, computer supporting team, students. No, it's not a lonely job.
So, when did you realize that computer science and computational work is a key part of research in physics?
Very early in my undergrad, it was at the end of my second year. There are some fields in physics that In fact, outcomes and answers can be obtained using a tool, computer. Yes, there is a computer science, but then there is this field of computational science, that it is the field that we use the computer to solve physics problems. And then maybe this is a good option for me. Only at the end of my undergrad is that I realized that I like it also, a particular field in physics called it condensed metaphysics, that uses also a lot of computers. And then it was when my decision for my graduate studies was made.
Can you explain just a bit what condensed matter physics is?
Yes.
Very broad question, but
Condensed metaphysics is a very broad area, and it concerns to anything that we can figure it out about matter. And because yes, everything that is around us is matter, is a really, really broad field. I joke a lot with Pooja that she actually wants to make me out of a job because she wants to study antimatter, and I study matter. And I already joke, and we were, you want me out of a job, right? Like, so I decided to specialize myself in the part of condensed matter physics that is study matter at really tiny, tiny, tiny scales, nanoscale, nanometer sizes, and nanoscience research, or also referred also to nanotechnology. And this prefix nano means 1 billionth of a meter. We take a meter and imagine divided in 1 billion parts. This is the kind of the scales of the materials that we investigate. It's just that I don't study materials in a laboratory, or I manufacture the materials, or I synthesize them. My laboratory is a computer. So what we do is that we code the laws of physics, of how the atoms interact, and everything. We try to mimic reality into the computer. And but then after that we have to process the output and everything, and see if the physics makes sense. If it makes sense, we are good to go. Otherwise, we need to go back and revise the physics laws of the computer code. And it can go both ways. It can be that an experiment was already run, and the experimentalists wish to understand further what they are obtaining, what they are visualizing. Oh, we got this curve. What this curve means, what is happening there inside the material. Then computer simulations can assist in this aspect, and it can also go in the reverse. We create a computational model that even might not have a priori an experiment done before, and the experiment can come as the perfect verification if that computational model makes sense or not.
what are some examples of the simulations you do on materials?
Recently, we are working with other different types of nanoscale materials. Now it's more towards metallic nanowires. We also test how good of an electrical conductor they are, how good of a thermal conductor they are. Because we are in a computer, in synthetic materials, we can do any sort of virtual experiment. We can subject them to mechanical deformation, see how they react. And all of this, we do these virtual experiments with computers. If we compare telephones or computers 10, 20 years ago, they were massive gadgets. And then nowadays we have practically we have mobile phones that are essentially computers. We can do so much with mobile phones, and this is a result of this miniaturization of circuit components coming from research in nanoscience and nanotechnology. Yes, and I decided all that this is the off information, that I decided to do computers because my feeling is that if I would go to a laboratory, I would break everything.